Hello, this is Reggie York. I'm going to talk about the normal distribution and the standard deviation, two critical concepts in regard to statistics. Let me tell you what this presentation is about. The normal distribution, which is depicted by the bell curve, which is the basis for the computation of the standard deviation, which is a major element in various statistical formulas. So the normal distribution is the way things normally are distributed. The bell curve is a way to depict that, and it's the basis for the computation of the standard deviation, which is the basis for many statistical formulas. So perhaps it's useful to understand a little bit about the bell curve and the normal distribution in order to understand some basic things about statistics. Let's talk about the normal distribution. It's the way social variables tend to group with more people around the middle than the extremes. For many social variables like IQ score, weight, height, and so forth, the greater number is in the middle, and the number of people in each category going away from the middle becomes less and less as you get further from the middle. That is the way that things normally are distributed. I'm going to show a very simple depiction of the normal distribution. You can see here that across the bottom are different scores, and you see on something, let's say this is self-esteem, and the highest score is a 9, the lowest score is a 1, and you can see that John had the lowest score for self-esteem, 1, and he was the only person who had a score way down there. 2 people, Mary and Bob, had a score of 2. 3 people had a score of 3, 4 people had a score of 4, 5 people had a score of 5, 4 people had a score of 6, 3 a score of 7, 2 a score of 8, and 1 person had a score of 9, the very highest possible score. So as you can see from the two extremes, it goes from very few people, it increases up to the middle, where you find the most people, and then it comes back down like that. That is the normal distribution. This is something that would not be a normal distribution. If you found this to be true, you would not have a normal distribution. As you can see, 5 people had a score of 1, 4 a score of 2, and so forth. Jan, who had a score of 5, was the only person in that category. Then it goes back up again, so that you have the largest numbers are at the two extremes. Well, that's not a normal distribution. That's not the way things normally are distributed in social variables. The standard deviation represents how many people are in each category from the middle of the distribution. I want to tell you about the average deviation, not because you're probably going to use it or see it very often, but because it'll help you understand a little something about the standard deviation. The average deviation is the average amount that people deviate from the mean. You would subtract each score from the mean. So now you have a deviation score for each person. Then add up all those deviation scores. Then take the average of those deviation scores. That would be your average deviation. The standard deviation tells us the same thing as the average deviation, but it is computed differently, and therefore the number of the standard deviation will not be exactly the same as the average deviation. The standard deviation is used in statistics because it takes into consideration the normal distribution, which is a normal reality for social variables. Here is a way of depicting the normal distribution and the bell curve. This is called the bell curve because it looks like a bell. And you can see that the 0 is the middle. Let's say we're talking about IQ scores, and the IQ of 100 is the average. That would be right here in the middle. So if you have an IQ of 100, you would be 0 standard deviations from the mean because you are right there at the mean. However, because the standard deviation for IQ is 15, That means that there are 15 IQ points between here, and here. Between 0 and +1 are 15 points. So if you have an IQ of 115, you are +1 for standard deviations from the mean. You're 1 standard deviation above the mean. If you have an IQ of 85, you are 1 standard deviation below the mean. As you'll see, of course, when you get further away, you have fewer and fewer people. This is an IQ of 115, this is an IQ of 130, this is an IQ of 145, and you can see when you get down here, we're talking about very few people. And when you get way over here, we're also talking about very few people. This is the normal distribution, this is the bell curve, and this is a depiction of standard deviations from the mean. Here is the normal curve depicted with percentiles. In case you were interested here, the 50th percentile is exactly the average. So if you are at the 50th percentile for grades on a standardized test, that means that half of the people who took the test did better than you, and approximately half of them did worse than you. You're right in the middle. And the higher you go, of course, the higher is your percentile. When you get way up here, you're in the 99.9 percentile, which means that you scored higher than just about everybody. Over here, way down here, that means almost everybody scored better than you. But this is a way of showing the percentiles in regard to standard deviations and so forth. Statistical significance is important here, or that is, it's relevant to the standard deviation. 2 standard deviations from the mean represents 5% of all people, half of whom are 2 standard deviations above the mean and half of whom are 2 standard deviations below the mean. The reason that's important is the amount of difference between the mean is the standard deviation for determining statistical significance in the social sciences. So when you are 2 standard deviations from the mean, you're in a category that has less than 5% of people, and that's where we get sometimes a p-value of 0.05. That means that if your score, your mean score, for example, for a particular group, fell into one of those 2 extremes, where only 5% exists, then you would conclude that your particular people or your scores or whatever are significantly different from the average. The z-score is the number of standard deviations from the mean. Using the example of the IQ test, if you have an IQ of 100, your z-score is 0. If you have an IQ of 115, your z-score is 1, because you are 1 standard deviation above the mean. And here is another way of saying the same thing I just said. If you have a IQ of 100, the standard deviation is 15, you'd have a z-score of 1. If your IQ is 1, or if your z-score of 0.5, it would be the situation if you had an IQ of 107.5. That's halfway between 1 standard deviation and 0 standard deviations. T-scores. The t-distribution is slightly different from the normal distribution and is used for some statistics to determine significance. It's used when the sample is small, and you'll see that there are a number of tests. The two-tailed t-test is used when you do not have a basis for predicting the results, and you want to know if the scores fall either significantly above or below the mean. However, the one-tailed test is when you do have a basis. If you have a directional hypothesis, let's say you say men will report higher salaries than women, you're saying which direction it's going. You're not simply saying there is a difference. You're saying males will report higher salaries. In that case, the one sample t-test would be the one more appropriate. And the question would be, is it true with regard to that particular tail of the bell curve? Which of these is better in regard to statistical significance? Your sample size is 30 and the standard deviation of gain scores for your clients is 4.2, or your sample size is 30 and the standard deviation of gain scores is 2.3. Which is more likely to show statistical significance? Well, number 2 would be because the standard deviation is smaller. And in this particular case, when variance is smaller, statistical significance is going to be greater. Let me summarize briefly. The normal distribution is the way that human variables are usually distributed, with greater numbers in the middle and much smaller numbers as you get at the extremes, either on the positive side of the mean or the negative side of the mean. The bell curve depicts that distribution. The standard deviation is a measure of variance and shows how much one score is from the mean and is used in many statistics. The greater the variance, the less likely you will find statistical significance. I hope this will be helpful to you in your examination of statistics.